Hello guys, I'm a teacher Limboka Sajugi Masame. Welcome to Limboka Physics. We have a question from Halliday and Resnick and Walker. The question 62 from chapter 33, the concept of reflections and the refraction of light. We have a catfish that is 2.00 meter below the surface of smooth lake. What is the diameter of a circle on the surface through which the fish can see the world outside the water? Another question is, if the fish descends, does the diameter of the circle increase, decrease, or remain the same? Let's consider the diagram below that is illustrate the concept, the three different concepts concerning the reflection and reflection of light on the plane surface. Here, when we take a look on the first case, we have a fish here, and the eyes at side C and the eyes at side F. This is a catfish. And for the first case, let us consider when the light from the object O incidents at point P and get refracted at point C. The fish will see the image of object O at a point S, from point R to point S due to refractions. As you can see here, the extrapolated refracted rays is intersecting with the normal rays at this point S and forming an image of object O at point S. And now we will have a two height here, the height QR and the height QS. For this height QR, this is the real height for this object, and the height QR, this is the apparent height for this object. Now we know that due to refractions, fish will see the visual image and displaced from R to S. This visual image is displaced from its original positions. Let us see how we can link refractive index of the any media with this refractory angles and incidence angles, with this displacement, apparent displacement from the real position. We must consider two triangles, the triangle PQR and the triangle PSQ, a triangle which has a common PQ, common opposite. Okay, now we know this is R and this is R. This is the opposite angle from this normal line, and because this R is the same as this R, this is because this is the alternating angle. This one, which is incidence angle, is equal to this angle. This is two angles are alternating angles. Okay, let us now see mathematics how these things are linking. Okay, we have PRQ and PSQ as I've stated. Now let us find the sign for incidence, sign for refracted as opposed to hypotenuse. And from Snell laws of refractions, we know that refractive index for water, where we have sign of refracted angle, and the refractive index for air, where we have sign for incidence angle. Then we substitute these values, this sign, then we have QP and QP cancel out because these are common opposite, and now we remain with expression as you can see here below. But for the observer's eyes to be very, very close to the normal, let us assume this eyes of the fish is close to the normal from this line. And then this angle becomes very small, and all of this hypotenuse becomes adjacent. Now we'll have hypotenuse PS, which is equal to adjacent QS, which is equal to apparent height or positions. And now hypotenuse PR is equal to adjacent QR, which is equal to real positions. Now our general formula refractive index of media is equal to QS divided by QR, where QS is equal to apparent height and QR is equal to real height. The general formula as you can see here, and for apparent shift from R to S, Now the apparent positions of this visual image is equal to a real apparent position minus a real positions. We know from the formula we make the subject real position, the apparent position, then we substitute here. Now our formula for apparent shift is equal to, we take out real h bracket effective index of any media minus 1. Okay, now let us go to the second case. Second case is when a light from object T or at the edge of this pond or lake is moving parallel on the surface and it gets refracted at points N to the eyes of the fish C. And this refracted rays is extended backwards and forming a visual image at point O dash. And this visual image is somehow larger, higher than the object. From this concept, this is a concept where we have a incident angle which is equal to 90 degrees, and now its refracted angle from this normal is equal to critical angle. Under these positions, we say that this radius of this we will have a radius of the circle for both sides, radius which of the circle of the cone NQC. And this is radius is from the center is from M, and now if this is C, this also is C, critical angle. Under these conditions is where the fish will be in a position to see on all sides of the edge of the lake or of the ponds any object. If there is a human being here want to catch this fish, either by aiming the spear on it or by using the pangas, this fish will notice it because of this concept of critical angle. Therefore, to this concept, you will not be in position to catch this fish easily by using either to throw a spear direct to it or to use a pangas. Okay. Now, for this case, let us see how we can get the radius NM. Radius NM is obtained by considering the triangle NMC. Remember, this radius is, when the twice this radius is equal to the diameter of this cone, diameter NQ. Okay, and something to note is that on this surface is where there is enough light that nothing on this surface cannot be seen by the catfish inside. Okay, from the concept we consider triangle. And now for sign for a refracted angle, this is refracted angle or incidence angle according to principle of reversibility of light, that lights that move through the path can also go out through the same path. That is entering the same path and can go out through the same path. Okay, then this will change this angle to be incidence and this to be refracted. Don't let it confuse you. Okay, we have now, as you can see, for refractive index of angle of water, then the sign for this incidence C, and now R is equal to 90 degrees. Now sign for 90 degrees is equal to 1. Refractive index of air is approximately equal to 1. Then we have a formula, as you can see here. This is for NC. This is the adjacent hypotenuse NC, and NM, this is our NM, this is equal to our radius opposite NM. Then we define NC for a small angle if we have a known critical angle. For large angle, for there is no a small angle, and if we don't have to this C, then from Pythagoras theorem, so we'll have these relations, and then we define these relations. This square roots MC is equal to depth of the catfish H, and the NM is equal to radius of the cone, and then we substitute the formula. We have another formula here. Okay, for a given critical angle C, the depth H can be calculated as by considering the NCQ, the cone NCQ. Now NM from the relationship of tan for this critical angle is just the adjacent opposite to adjacent. Okay, when we link opposite to adjacent, we'll have R, which is equal to capital H, which is the depth of the fish times tan of critical angle. In diameter is equal to twice H times tan of critical angle. Now this is our second equations. Okay, let us see if our questions. We given h, and now we've given the value of h. Now let us find the form of the critical angle. Determine critical angle from this relation. Simply from these relations, now we find the arcsine of this reciprocal of this effective index of the media, and now we come to substitute into this question 2, and our diameter of the circle is equal to, as we can see here, 4.6 meter approximately. And our part B, the relationship between when the fish is descending, how the diameter of the circle will be. If the fish is descending, the diameter simply of the circle, we can see the relationship from the general formula, the equation 2, as d is proportional to h for the constant 2 and tan of critical angle. Now the h increasing as d increasing. Now it reduces the diameter of the circle of this cone NQC is increasing. Okay, and the third case is when the incidence angle now is greater than critical angle for this if f, and for this side for I is f, and this is other side from this point k and this point h. When you consider this circle is a circle where the critical angle is greater than c, at these conditions, fish will see the point h k as covered by this the image of the bottoms of the pond will be seen at the point HK. Therefore, the fish will not be able to see through this water to the outside world, to the air, because as you can see from here, this internal reflections that will take place here will be reflected on the surface HK, as you can see from the diagrams, as you can see from here to here. Then when it comes to undergo total internal reflections, to go to internal reflections, the surface HK will be full of this covered by this image, the image of fish itself and other parts on the bottom of the pond. But therefore, during these conditions, someone who is finding to catch this fish will be in a good position now to aim the spear on this fish, or to use pangas to cut this fish easily, because there will be no any light on the surface of the surface HK due to total internal reflections. Therefore, the fish will find itself that is already hit by the spear or cut by the pangas. Okay, this concept is how this local fishermen during night they go out and catch the fish, because during night there is no light on the surface HK. Therefore, it is easy to spear the fish and hit it and take it out or cut it by pangas. Okay, for this concept, this is how we use these questions to just explain the important three concepts concerning the refractions of light on the plane surface, while the object, the eye, the observer, is inside the water. Okay, thank you for watching. Please like, share, comment. Don't forget to subscribe this channel for more videos like this one. Thank you.